All right, guys, so we are going to go over these three examples right here in your slides presentation. Um, what we're going to do is we're going to use something called a T method. So you should have already watched your videos from Khan Academy. And so what we're going to do is we're going to go through these examples using our do-undo method. So I realized that, a lot of you could look at this and you could say, what number plus 7 equals 10? Well, we know that's 3. A lot of us can just see that right away, all right? But what I want you to get used to doing, because these equations are going to get more and more complicated. So I want you to get used to doing something called the T method. And what that is you basically draw T. And then on this side, you're going to write x plus 7. This is where your equal sign is. And then 10 goes here. So this T is always going to be right where the equal sign is. The reason why we do that is because we want to remember that what we do to one side of the equation has to be done to the other side of the equation as well. So if we're looking at this and we're thinking inverse operations, the opposite operation of addition is subtraction. And if we want to get x by itself, we're going to have to take away this 7. So we're going to do minus 7. But because I did it on this side of the equation and I want to keep my equation balanced, we also have to do it over here. So we're going to subtract 7 here. Now on this side, this plus 7 and minus 7, they canceled each other out. So all we're left with on this side of the equation now is x. And we still have our equal sign. And then now over here, we do our operation. So 10 minus 7 is 3. Now that's going to match what we said before, because we looked up here before and said, what number plus 7 equals 10? Well, we said 3. So we proved that. We actually solved for x. We isolated the variable and found out that, yes, it was 3. Now over here, this looks a little bit different because now we've got the constant over here and then the expression with the variable on this side. It's going to work exactly the same. So I'm just going to go ahead and make this T symbol here instead of copying it down. So it will work the same. So we still have to get this x by itself. We have to isolate that x. And we have to use opposite operations. Now, the thing that you might not notice is that in front of this 2, we have an invisible plus sign, because this is a positive 2. So if this is actually plus 2, because it's a positive 2, the opposite of that would be minus 2. Because we have minus 2 on this side, we also have to do it on this side. So this is just in a different order. So we can see that this number is positive because it doesn't have a negative sign in front of it. So that's why we got to make sure when we're looking at an equation that's in a different order that we pay attention to what sign is in front of it. If there isn't anything in front of it, then that's a positive number, a plus sign. So these two will cancel out. 13 minus, oh, I'm sorry. So then all we're left with is x on this side equals, and then 13 minus 2 is 11. So again, we can look up here. We can see that 2 plus 11 does equal 13. If I read it this way or that, 11 equals x, x equals 11, it's pretty much the same thing, but usually we would read the variable first, okay? So even if you see it like this, we would still say x equals 11.